when we start thinking about the data analytics cycle, question, the data, the logic, let's start thinking about a little bit about communication. Because as we going through and thinking about the logic, I might also want to be contemplating how I want to communicate this effectively. So communication of the results is critical. Now, you can wait and do all your analysis and then start thinking about the way you want to communicate it. But I think it's in your best interest in your discussion of the logic about what you want, what kind of output you want this to look like. What do you want this to look like? So as the analyst, if you just providing a table of data, like we've been doing, right? All these summarizations, these pivot tables, etc., has little meaning. It's just data. It does not convey a story. So by adding some visualizations, to your results, a story may begin to emerge. So in this script, and this is going to have several parts to it. It's one script, but there's going to be several videos on this. In this script, I copied the basic plot types and statistical plots from Matplotlib. Put this down. Matplotlib.org. Okay, from the website, and put them here. So not a lot of cleverness on my part, but just really to kind of illustrate them, because this is what I looked at. So when I was looking at it, I would be going to this particular website, and I went to the user guide. And okay, first of all, installation, I want to do that, draw your first plot. And then I said, okay, well, what are some of the examples? Or what are the plot types, right? So here I went to the plot types, and these are kind of the basic plot types. A line chart, a scatter, a bar, a stem, step filled between, right? So basic stuff, and I also put in some basic stuff and some statistical plots. Not all of these. I mean, these are all very interesting and different, but pie chart, histogram, a box plot, those are things that I think you'll likely see. But there's lots and lots of different examples. In future videos, we go through some of these more complex examples, adding other things like different kinds of markers onto it. We don't do a lot with images, but you can, different ways to do different subplots, statistics, etc. Right? So I use this pretty extensively. I think this is a good resource when you're trying to figure out, how do I want to convey this? Well, if I want a basic pie chart, I'm going to click in here, and guess what? Here's the script to do a pie chart. It's not that hard. So I want you to leverage all of these great resources out here, and what this script is going to do is it's going to at least walk us through some simple stuff initially. So we're going to go through each type. We'll will try to explore how to make adjustments to elements of each chart. Right? So it just, there's the simple stuff, and then we'll try to do some other things, right? As I said, I copied in this script, I copied the basic plot types and statistical plots. Oh, I already did that. I already said all that. I can't believe I'm repeating myself. So when we think of, this is what I wanted to say, when we think of charts and plots, we are generally dealing with two-dimensional art, right? All this is art. There are some items that could change or could be changed in each plot. Some of those things are the scale of the axes, the name of the axes, right? If it's X and Y, that kind of stuff. You can insert a legend. You can change colors. Maybe insert text within the plot. Okay? Those are just some of the examples. So this script, the code creates different types of plots. In later scripts, the code will highlight some of these changes that we can make. All right. So this is just in this script, the code creates basic plots or different types of plots. Later scripts the code will highlight how to make certain changes. All right, so we have to import if you haven't already installed it, right? And there's a couple of different ways to install it. We can go back over here, right? So if we wanted to go back to our user guide, and the installation quick guide, right, is conda install Matplotlib. Since we're using conda, since we're using Anaconda, this is the way to install it. All right, so very simple. Let's go back to our script here. So I've already installed it. We want to import matplotlib.py Python plot as PLT. I'm also going to, and I think I've got that, yeah, I'm also going to import NumPy as NP. All right, and what you'll see, I'm going to create data using NumPy. Right, we're not going to be using our data sets. We're just going to basically create some simple data that we can then, and I'm doing it this way so that you can also, if you went to their website, you'd see the exact same code. So we're trying to be consistent. All right. So here we go. Let's do a line plot, right? The first plot, a line plot. This first script creates a simple plot. The creation of the data is provided to you, right? And I think we pretty much use the same data all the time. The plot takes the X and Y data and graphs it as a line. The X data is 100 numbers, in a range from 0 to 10 using LINSPACE. You'll see this. Okay, so what LINSPACE in NumPy does, it returns evenly distributed numbers, evenly spaced numbers over a specified interval. Okay, the y data is just the sine function. You know, sine, cosine, tangent, all that fun stuff is just the sine function of the x data. All right, so this is how we're going to create the data. All right, very simple. Okay, so FIG, you're going to see this, AX equals PLT dot subplots, right? What this does is it defines AX as the figure. Okay, so this, what we're calling it AX, that's the figure. Okay. AX dot plot identifies the variables to plot within and the width of the line. If you wanted to make it wider, you could increase the line width. You could increase the line width. To 5 and see what happens. The AX.set establishes the range of data. In this particular case, you're going to see it goes from 0 to 8. So while I have data that is up to 10, I'm only going to plot a range from 0 to 8. And the X and Y tick marks are set as from 1 to 8. Okay? For each of these plots, play with the parameters and see how it changes. See how it changes the plot output. All right, so we've kind of set it up, right? Now we're going to see all of this stuff happen. All right. So we're definitely going to put this as a cell. All right. So the first thing is this is what we're going to do here is this making the data, right? And put a documentation in there. All right. So first, X is equal to np.linspace. And we want to make this linspace is going to give me a linear spacing, evenly spaced from 0 to 10, and I want 100 numbers. That's what that's going to do. It's just going to give me a series of X, right? And I can run this, and up here in my variable view, guess what? Because I haven't run these. Let's run these. See, I forgot to run both of those. I got to do that first. Now I can run this. And now here's my array of floating variables, right? I can open this data set, and here they are, 0, 0.101, 0.202, 0.303, all the way, 100 numbers, all the way to 10. Okay, so that is my X. So now the next thing I'm going to do is create my y. Well, my y is equal to, and I don't want it to start at 0, so I'm going to add 4. It's just where it shows up on the graph. I want it to be a little bit kind of in the middle, right? Because my tick marks are going to be between 0 and 8, so I'd like it to start in the middle there. So it's going to be 4 plus 2 times np.sin. Let's put some spacing in here so it is a little bit more apparent. Of 2 times x. Okay, so all this is just a sine function. I'm taking the sine function of x. All right, so we can now put in and run y. And now I have another array of values. All right. Okay, that's just creating the data. Now let's create the plot. All right. So first thing, I want to define the figure, fig, comma, and then ax is equal to plt dot subplots. That's the function. So now figure is, now ax is the figure, and it's a plt because we've got plt, it's Matplotlib plot, py plot, it's labeled plt, and subplots. That's the function. Okay. The next one is ax dot plot, and we want to plot x. We want to plot y, and I want to have the line width equal to 2.0. All right. The next thing we're going to put in here is we're going to put in the set. So ax set x lim, x limit is going to equal 0 to 8. The x ticks, this is setting the tick marks, is equal to a numpy, a range between 1 and 8. All right, comma. I'm going to go down to the next line here. Will that do the next? Oh, I've got, this goes here. I missed, there we go. Now we're good. Okay, now I can go. There we go. That makes more sense. Y limit, I want that to equal 0 to 8, comma, and y ticks is equal to np, a range, also from 1 to 8. Okay, and now I should have that good. The last thing we want to do is plt show our plot. All right. So I'm going to run this entire. I'm going to run this entire cell. It's going to run it. Well, I'm going to do it individually. So let's run each thing individually. So let's run this first one. All right. There we go. Here's our blank plot. It came up on plots, right? Here's our variable explorer. Here's our plot. Now we're going to plot x and y with a line width of 2. Notice the tick marks are 0 to 1, 0 to 1. We're going to create a line. We're going to create the actual plot. All right. So the plot is in there. I think we're going to find out. Now we're going to set the limits 0 to 8 and 1 to, and put the range in there, put that in there. Okay, and now we're going to show the plot. All right, now I got to figure out what happened. Why didn't it work? Let's see. np sine 4 plus 2 times that. This all seems to be working. X, Y, line width 2. Well, let's run the whole thing as a cell. There we go. Trying to run these individual lines doesn't seem to work. And this happened to me when I was trying this on my own. You've got to run everything at the same time, right? You can't just do this, because now it's not picking up any of this. So at a minimum, even if you don't put your data creation, you should always have a cell for creating the plot. So all of these lines have to run within the same cell in order for you to get this plot, or you're going to be left with this mess. All right? So running all of it at the same time, that is going to be your best. Now, I can always get rid of any of these. I can remove that plot, and now I've got this last plot. So here's my plot. I wanted it to start at 4, and it did. And I've just got this nice sine wave. So nice, quick and easy little